This video is brought to you by Altium 365, where the world designs electronics, and Octopart, the fastest search engine for electronic parts.
Get a free copy of Altium software using the link provided in this video description. Plus, when you sign up for an Altium Designer free trial, you will get Altium 365 and 25% off discount.
Hi, and welcome again to another video. Today we're diving deep into the fascinating world of the Arduino R4 Minima. If you are curious about how this remarkable board circuit works and want to understand its board topology, you're in the right place. Arduino R4 Minima is not your typical microcontroller board. It's packed with unique features and a topology that sets it apart from other Arduino boards. Whether you're a beginner, looking to expand your knowledge, or an experienced maker seeking to harness the full potential of this board, this video will provide you with a comprehensive understanding of its inner workings. In this tutorial, we'll explore the board's key components, examine its circuitry, and unravel the secrets behind its topology. By the end of this video, you will be equipped with the knowledge needed to create your own innovative projects with Arduino R4 Minima. So let's jump right in the circuitry and board topology of the Arduino R4 Minima. But before we do, if you haven't already, make sure to subscribe to our channel and hit the notification bell so you never miss out on exciting Arduino content. Alright, let's get started. Right now, I'm excited to share the schematic sheet of the Arduino Minima with you. As you can see here on my screen, this is the heart and the soul of our board. We're going to examine it together part by part to understand how all the components and connections come together to make this board tick. We'll break it down step by step, dissecting each component, connection, and pathway. By the end of this walkthrough, you'll have a crystal clear understanding of the inner workings of this incredible board. So grab your notepads, get ready to dive deep, and let's explore the Arduino Minima's schematic piece by piece. Now, let's take a look first at the microcontroller circuitry. The Arduino UNO R4 microcontroller is powered by the Renesas RA4 M1 32-bit Cortex-M4 processor. This microcontroller provides a significant boost in processing power, memory, and functionality compared to previous versions. The RA4 M1 series microcontroller has the features of 256 KB flash, 32 KB SRAM, 8 KB data flash or EEPROM, real-time clock, 4 times direct memory access controller, up to 14-bit ADC, and up to 12-bit DAC, op-amp, and a 1 CAN bus. You can see also here in the pin 11, 39, and 21, the VCC USB is the output of the internal USB LDO, providing 3v3 in the peripherals. Next is the reset button and the headers. The reset button on the Arduino Minima is a user-friendly feature that allows you to reset the microcontroller quickly. Pressing this button will restart the program running on the board, which can be very useful for debugging and reinitializing your project without having to disconnect and reconnect the power source. Next, the Arduino Minima is equipped with various headers, including digital and analog input-output pins or I/O pins, power pins, and communication pins. These headers serve as connection points to attaching external components such as sensors, actuators, displays, or other modules. The header provides a simple and organized way to connect your hardware to the Arduino board, making it easy to expand and customize your projects. Overall, the reset button and headers on the Arduino Minima contribute to its user-friendly design and makes it a versatile platform for both beginners and experienced makers and developers. And also, the Arduino Minima board has the feature of SWD or Serial Wire Debug Connector. This connector is typically found on advanced development boards like Arduino Minima for debugging and programming microcontrollers. Arduino Minima is a minimalist board designed for basic and complex electronic projects. It is included of debugging or programming capabilities through SWD. Now let's go to the USB connector circuitry. The Arduino R4 Minimo board is equipped with a USB connector. This means it has a native USB capabilities for direct programming or communication with a computer like some other Arduino boards. The UNO R4 Minima has one USB-C port used to power and program your board as well as send and receive serial communication. Also, you should not power the board with more than 5 volts via the USB-C port. Next is the buck converter circuitry. The Arduino R4 Minima board features a buck converter, a type of DC to DC converter that allows you to efficiently step down the input voltage to a lower level. This is especially useful when you have a power source with a higher voltage than what the board requires. The buck converter on the Arduino R4 Minima helps regulate the voltage and provides a stable power supply to the board's components, ensuring they receive the appropriate voltage levels for proper operation. It is crucial components for a power management in the board and contributes to its overall efficiency and performance. The Arduino R4 Minima uses an ISL854-102FRZ buck converter. It steps the voltage down to 5 volts. The VUSB barrel jack connector and the VN pins are connected to the buck converter with the Schottky diodes in place for reverse polarity and overvoltage protection respectively. Next, we go to the LEDs. The Arduino R4 Minima board is equipped with LEDs or light emitting diodes. It serves as the visual indicators. These LEDs are commonly used for various purposes in electronics. On the R4 Minima board, they are likely used for tasks like indicating power status, data transmission, or debugging. For this case, it is used for TX, RX, power, and SCK LEDs. LEDs are energy efficient and emit light when current flows through them in a forward direction. They are often used to provide feedback to users or engineers about the board status or any ongoing processes. The specific function of the LEDs on the Arduino R4 Minima board is used for the RX, TX, power, and SCK. Next, we go to the CC resistors. In the Arduino R4 Minima circuit, the CC resistor or the current sense resistors are components used to measure the current passing through a specific part of the circuit. These resistors are designed to have a known resistance value and are usually placed in series with a load or component where current measurement is required. For this case, in Arduino R4 Minima, it uses a resistor with 5.1k ohms resistance and is connected to the ground. The main purpose of CC resistors is to monitor the current flowing through a circuit and provide this information to other parts of the circuit, typically for feedback, control, or monitoring purposes. By measuring the voltage drop across the CC resistor, you can determine the current passing through it. In the context of Arduino R4 Minima board, the CC resistors may be used in various ways, such as monitoring the current consumption of specific components, ensuring safe operating conditions, or providing current-related data for software control. The specific values and functions of these resistors would depend on the design and requirement of the board circuitry. Now let's take a look at the ESD protection circuit. The ESD or electrostatic discharge protection circuit in the Arduino R4 Minima is a crucial feature designed to safeguard the board and its components from damage caused by static electricity. ESD events can occur when an electrically charged object or person comes into contact with the board, potentially leading to the failure of sensitive electronic components. The ESD protection circuit in the Arduino R4 Minima typically includes various components. For this case, it uses a TVS diode. ESD protection diodes, often known as transient voltage suppressor or TVS diodes, are placed strategically on the board. These diodes provide a low resistance path to the ground for any excess static charge, diverting it away from sensitive components. They allow current to flow in only one direction and have a fast response time to protect against sudden voltage spikes. In conclusion, we've taken a comprehensive tour of the Arduino R4 Minima's schematic. Understanding these components and their roles is essential for harnessing the full potential of this powerful board. As you embark on your projects with the Arduino R4 Minima, remember that knowledge is the key to creativity and innovation. Thank you for joining us on this journey through the Arduino R4 Minima schematic to unlock its full potential. Make sure to stay tuned to our upcoming video where we'll guide you through the process of designing and programming with this incredible board.